This is the brief on the superposition principle in electrostatics in waves. So, what is the superposition principle? You can think of it as a fundamental tool in physics that lets us solve simple problems, like a single point charge or just one wave, and then combine those solutions to figure out far more complex scenarios. Let's zero in on three key takeaways. First, the whole thing works because the governing equations are linear. And this mathematical linearity is exactly what allows for the simple algebraic addition of individual solutions to predict the total combined state. Second, when you apply this to electrostatics, it's very straightforward. The total potential field, it's just the arithmetic sum of the potentials from each charge source. So for 2-point charges, you literally just add their individual potentials. This is how we predict complex electric fields, like the one from a dipole. Finally, while wave propagation also relies on this linear summation, the result is way more dynamic. That's because waves have a phase relationship, right? So their superposition leads to the incredible effect of interference, where the resulting energy distribution is drastically altered. Understanding this linearity reveals why we can simply add fields and potentials in electrostatics, even as it causes those dramatic interference patterns you see in wave mechanics.